of all, I want to say I'm really glad to be here again. So the first time I was in Toronto was 2 years ago, and I was also talking about testing, and it was an amazing experience, and it's an honor to be here again, and especially it's an honor to talk after people like Daniel. So as always, he did a great job at highlighting what's coming next to Nuxt. And in my talk, we will take a closer look at how we can test Nuxt applications more effectively, especially when you are working in a microservices architecture. So at my previous job, we built a software system that looked something like you can see here. We had a Vue single-page application, and this Vue single-page application got all its data from various microservices. And those microservices got their data from databases. And this was fine, and especially when it came to testing, this system was relatively straightforward to test. What we did is we wrote application tests for testing the single-page application, and in regards to the microservices, what we did is we mocked all the requests to the different microservices, or we intercepted the requests to the microservices, and that way we could test our Vue.js single-page application in isolation. But then we decided to do something different. At some point we decided using only a single-page application, talking directly to microservices isn't the way to go for us, because that way the microservices had to do some things to prepare the data in a format that fits the front-end application, and we didn't want to do that because our microservices should be independent of the consumers. The microservices should deliver data to various applications, to mobile applications, maybe even to desktop applications and other systems, and they shouldn't have any code in them that prepares data in a format that's useful for the single-page application only. So we decided we need a layer in between. We need a BFF, or backend for frontend. And we decided to use Laravel as the technology stack to build this BFF. And in this BFF, we could do things like fetching data from various microservices and prepare the data so it fits the needs of our client-side single-page application. But with that, we had a problem when it came to testing. But before we take a closer look at the problem and how we solved it, a couple of words about me. So my name is Markus Oberlehner, and since September I'm working for the Austrian Federal Computing Center, and there I'm working with the team who is responsible for making paying taxes easier for the Austrian citizens. If you want to follow my content, you can follow me on Blue Sky, and my Blue Sky handle is also my website. And if you're interested in testing in particular, you can check out my book I wrote about the topic. But let's move on. Let's see what this talk is not about. This talk is not about unit testing. This talk is also not about component testing. This talk is particularly about application testing, about application tests. And to clarify what I mean with application tests, you might call those tests maybe integration tests or end-to-end tests or something like this. I prefer to talk about application tests in this sense because we are testing the application, and so I think it makes sense to call the tests like that. And what those tests are, typically we use a tool like Playwright or Cypress, for example, to control a browser and run our application in a real browser and interact with it like a real user would do. But especially when we are talking about the microservices architecture, we want to test, or our application tests should be built in a way that they don't rely on the external microservices, and we will see why later. And another thing I want to clarify is that generally speaking, there are two types of tests, and what I talk about is only relevant for one kind. But first, let's take a look at the kind of applications the type of testing I want to talk about is not relevant. For a monolithic architecture, what we talk about today is not that relevant. And the second way of building applications is using a microservices architecture, and this is what I want to focus today. But to clarify the differences, let's take a short look at the monolithic architecture and how we might approach testing there. So if you build a monolithic application, you typically have your application built with something like Vue.js or Nuxt or Next or whatever, and this application gets its data from mostly a single database, maybe sometimes even multiple databases. As I said, you build such applications using a variety of tools like Next.js, Nuxt, Laravel, Spring Boot, or Rails, or you name it. But the important thing is you build your application in one framework and have a single database, and this is your single application. And with that, you can use database seeding when you want to test this application or when you want to test various scenarios. So you write a test for the whole application, including the database. You don't need to mock anything. You really can test the application as a whole, and you write some seed data in the database, and then you can write your test scenario. And this might look something like this. Imagine you have a shopping list application. So an application where you put in, for example, bread and butter, and then you are in the grocery store and you can check the list of items to see what you need to buy. And for an application like this, you might write a test where you say it should be possible to remove an item from my shopping list. And for this, so that I can test this, I need some data first in the database. So I can, if you are using Prisma, for example, you can say you can fill your database with the data you need to write your test scenario. So much for monolithic applications. And if you can help it, I highly recommend you build monolithic applications and you stick to your monolithic architecture. But because not only is testing much simpler when you build monolithic applications, but a whole lot of other things are also simpler. But if you can't help it, and if you are working in a large enterprise, for example, or you have other good reasons, and you think you profit or you benefit from using microservices, then this is what the rest is about, how we can test microservices. How does a microservices architecture look in a very simple graphic? We can see we have our application getting its data from various microservices, as we already saw before. And when testing applications in a microservices architecture, we can do it like I showed you at the beginning. We can write the test for only our application and mock the requests to all the services. At least we can do this as long as we have a single-page application, because with a single-page application, we are able to intercept all the requests the application makes to the microservices. And how would this look like? Again, we have a test stating it should be possible to remove an item, but now we have a very over-engineered solution, at least for this kind of application, where we get our shopping list items from some microservice, and with a tool like Playwright, like in the example you can see here, we can say we want to intercept this request to this microservice, and whenever our application fetches data from the microservice, it should respond with the JSON you can see here instead of making a real request. But there is a big problem. What are various problems with this approach when testing microservices-based applications? In the beginning, I said, as long as we had a single-page application, everything was fine. We could intercept the requests made to our microservices. But then we introduced this backend for front-end layer. And with this backend for front-end layer, things became a little bit more complicated when it comes to testing. Because now our single-page application only made the request to this backend for front-end layer, and the backend for front-end layer then got its data from the microservices. Why is this a problem? This is a problem because with a tool like Playwright or Cypress or any other browser automation test tool, we can only intercept requests between client-side application running in your browser and the server side. But with the setup with the BFF, it means we have browser-to-server requests, so requests from our JavaScript application to the BFF, and we have server-to-server requests. And the more important requests when it comes to testing and mocking are those server-to-server requests, but with tools like Playwright, it's not possible to intercept those requests. So we had a big problem because now our tests were only testing part of our whole application. So our whole application consisted of the single-page application, client-side part, and the BFF part. But because we mocked the requests between the single-page application and the BFF, we didn't test the whole application, but only part of it. And things get even more complicated, or even more impossible, should I say, when we build a Nuxt application in a microservices environment. So I'll let you read those few lines from the documentation about direct API calls real quick. So Daniel was talking in his previous talk about further optimizations that they plan when it comes to data fetching in Nuxt. And this is really amazing what they do there, and I'm looking forward to those changes. And they did already optimize some stuff with Nuxt 3. And this is what you can see here. So with Nuxt 3, you have your client-side code, basically, or should I say isomorphic code that runs on the client, and you have your server routes. And the server routes, so in the file directory, you have server/API, and in there they live your server routes. Your server routes are sometimes called via HTTP for client-side navigations, for example. But if you arrive at the page for the first time, or if you do a hard reload, for example, then there isn't any HTTP call from the client side to the backend at all, because Nuxt optimizes this to save this HTTP overhead and directly calls the server-side function, the server-side route as a function. And although this is amazing when it comes to performance, for testing, it makes things even more complicated, because you can think about Nuxt.js the same way as the architecture I showed you before. Like you have basically your front-end part. I put it in quotes here because the front-end code doesn't only run on the client side, doesn't only run on the browser, but it also runs on the server for server-side rendering. So it's isomorphic.js. And you have kind of your BFF layer. It's not really called that way, but you can think about it like a BFF layer in the form of server routes. And as you can see here, if we want to test this application, we can't even mock the requests from the front end to the BFF layer anymore, because sometimes there is no HTTP request at all. So how can we solve this? Or what is the big problem here? The big problem here is that mocking doesn't work with the BFF pattern. Because although when you have a regular BFF, it kind of works, you can do it, but then you don't test your whole application, and you always want to test your whole application and not only a part of it. So regardless if you're using Nuxt or building an application using a traditional BFF built with another technology, mocking in a microservices environment doesn't really work. So much for the first big problem. The second problem is then when we use mock data, we can't be sure that the mock data is in sync with what our microservices are delivering, which data our microservices are delivering. So with mock data, you can do something like you can see here. You can say, I don't like that there is a name property, and I want to change it to title property for whatever reason. And Then you make the changes in your code to reflect this change, and then your tests would pass. But then you deploy it to production, and everything will fall apart, because obviously just changing your mock data doesn't affect your microservices. So you can have mock data that is out of sync with whatever you are getting from your real microservice. And this can also be a big problem in more complicated environments. So the second big problem with mocking in this scenario is that mocked tests do not break on API changes. So ideally, you would want your tests to break when your mocked data is not in sync with your microservice, but there's nothing that guarantees that. So what I want to propose is that we use a technique called contract testing to solve this problem. So that we use contract testing whenever we deal with an architecture like you saw before, where we have microservices and front-end applications with a BFF layer in the form of Nuxt or some other BFF layer. And for this example, I want to show you a shopping list application, as I described earlier, which is a Nuxt application which gets its data from a product service. So this is a very simple example, and obviously, if you would build an application like this, I highly recommend you stick with a monolithic architecture, but for demo purposes, I wanted to keep it simple. And for reference, I will show you this later when we look at the actual code again. For reference, this is how this whole system works when we use contract testing. So we have our product service on the right, and this product service now publishes its contract with the outside world in the form of an OpenAPI specification in a global contract store. And then, when we test our application, we can get all the relevant contracts with all the services we need, in this case only the single product service, start up a stub service, which you can see at the bottom, and now when we run our tests, our shopping list app doesn't request the real microservice for our data, but the stub service. Okay, so let's take a look at this, how this looks in practice. So here you can see the shopping list application. Let's start the service real quick. So this is the product service, and they also need to start the shopping list application, which is a Nuxt application in this case. And now we have here this shopping list where we can add items. So this is the shopping list. And by default, it makes requests to the product microservice. So we can see here, we've created the product, and then it fetches all products and so on. So this is our application. And when we take a look at the code here, then we see we have a directory for the shopping list, and we have a directory for the product service. And in the product service, which is a Node.js-based API service, we have a contract directory. And in the contract directory, now we have two things. First of all, we have a YAML file, which is the specification file. Basically, it's contract. So it is an OpenAPI specification. Who of you is familiar with OpenAPI specifications? Who is using them? So a few, yeah. I highly recommend to check this out if you're especially if you're working with microservices or when you're building HTTP APIs. So with OpenAPI, we can specify how our HTTP endpoint looks like. So we can say, for example, that we have a products path, and when we make GET requests to the products path, then there can be two kinds of responses. There can be a 200 response and a 500 response, for example. And we also can specify the format, which data it returns. So in this case, we say it returns an array of products. And when we take a look at the product specification, then we say a product has an ID, and a name, for example. Okay, so yeah, and other than that, we also specify that that we can handle post requests and so on. And when you are working with specifications, or when you are working API first, then what you do is you first write this specification and then you implement your HTTP API. And then there are tools that enable you to validate that your HTTP API actually behaves according to the specification. And a great tool I can recommend you to do this is, to use for doing this is Specmatic. Let's open this real quick. So Specmatic.io. And this is a tool for contract testing, but not only for contract testing, but also for running a stub server based on this contract. So let's take a look at how this works. Now, this was our HTTP service. And now let's take a look at our Nuxt application consuming or getting its data from this HTTP service. And here, when we want to test this, then we can say, again, in our test directory, we have a contract directory, and then within this contract directory, we have examples. And in those examples, we can say, whenever we make a GET request, for example, to the products endpoint, then it should return this data. So we can use this to inform the stub server, which we start using Specmatic, about what data we want it to return to us. So much, it looks very closely to what we can do, right? Looks very much the same to what we can do with mock data. And conceptually, there are similarities, definitely. But with the important difference that because we are using a real stub server and not any form of intercepting requests or something like that, this also works with applications using a BFF or with Nuxt applications, like in this example. And even more, so much for the first problem I mentioned, but even more importantly, it also prevents us from simply changing the mock data, but not reflecting those changes in the service as well. So for example, if I would change this property here, and I run the tests. So for running the tests, I need to do things before. First of all, I need to run our application with the test configuration, and in this test configuration, we simply tell the Nuxt application to use our stub endpoint. I can show you the environment variable. So here we say for the product service, we want to use our stub endpoint instead of the real endpoint. So let's start the application with this configuration. And then we also need to start the stub server itself. And this is using Specmatic, and the output here tells us that it uses the contract provided by the product service and also the examples we saw here. Because, how does this work? This does work the following way. The stub service gets all its data from the global contract store. So in the contract store, we publish the contract with the product service and also the examples of all the applications. And then we can start the stub server using these specifications to power our endpoint. Okay, and now we are ready to start our test with Playwright. I open it in UI mode so we can see what's going on. Let's zoom in a little bit. And for this simple demo, I only have a single test which says it should be possible to add a new item to our shopping list. And we can run this test, and if you remember, I've changed the following thing. I changed the title here, the name here to title, And now our test, before it even starts running, because obviously we also didn't change the code, so if it wouldn't fail here, at least it will fail at the code. But imagine we would have changed the code, it would still fail, because now it tells us the product service contract hasn't a title in there, but it expects a name. So this way, the system prevents us from simply changing the mock data without really reflecting those changes in the service. Okay, but let's change this back real quick. So now we have the correct format again, and then we see the test runs correctly. So we open our shopping list application. There are already 2 items in there, and we can add a new item, and then we check that the new item is in the list, and this basically is our test for the simple application. And now we test the whole application from end to end. So we don't mock any data, we don't intercept any requests to our BFF layer, but we ensure the whole Nuxt application works correctly. And not only that, we also ensure that it's in sync with the service as well, because whenever we make changes to our mock files, then it checks whether those changes are in sync with the specification of the service. So now imagine we want to change something in the service. Now imagine in the service we want to change the name. Let's do it all at once. We want to change the name to title. And now what we can do on the service level is we can validate our contracts. So we can say contract validate, and then what it does, it checks the contract store for all the examples provided by all the consumers, by all the consuming applications, and then it does something really useful, because then it tells us this change isn't compatible with our applications, because it says us there is an app shopping list, and this app shopping list tells us in its examples that it needs a name, or that it expects a name and not a title. So this is very useful as well. But on the other hand, if we do a non-breaking change, as you should prefer when working with microservices, for example, when we add a description here, and we also add a description field there, and we run our validate function again, then it says everything is valid, because we made a non-breaking change. And now we would be ready to publish our new contract. So now the contract is published, and now when we start building, when we want to implement a description feature in our application, then we are ready to do this, because our new contract, our new service specification tells us how that there is a description field now available to us. So with this approach, with using contracts and stub services, or a stub service, I don't go to the slides. Oh, here we are. We solved the 2 problems that we saw earlier. So we solved the problem of our tests not breaking when we just simply change the mocks, and we also solved the problem that we only test a part of our application, because now we are able to test the application as a whole. And I know that 30 minutes for this topic are a little bit, is not enough time, so if you have questions, please come to me after the talk. I will be available, and I'm happy to talk to you about contract testing and how you can use it to build better Nuxt applications with it. So when we work with microservices-based applications, write better tests with contract tests, so we write more stable applications. Thank you very much.
Thank you, Markus. That was great. I always appreciate learning about patterns like this, because I tend to be a terribly lazy tester. or I guess we're recording here. I always have best practices with testing, just like all of you out there, right? Yes, yes. Okay, before we go to our break, we can take one question. Anybody have one for Markus?
What would you use as a contract store when you have a lot of microservices across different platforms or repositories?
Yeah, that's an excellent question. And I actually don't have a good answer because we experimented with a couple of tools. Unfortunately, I forgot the name of the most promising one, but I have to look it up and we'll tell you later. There are tools provided by the Google Cloud and so on, but they're all not great, I have to say. So our approach was then that at least at first we wanted to go with a very straightforward approach and use a Git repository. So push our contracts to a separate Git repository and fetch them from there. But yeah, I'm not 100% happy with the solutions out there yet, unfortunately.
All right, thanks. One more round of applause for Markus.